Hello, this video is going to introduce you to the sine law. So primary trigonometric ratios and the Pythagorean theorem can only be used for right triangles. And so for triangles that don't have a 90-degree angle in them, or if we don't know if there's a 90-degree angle in those triangles, we need other options for how we can solve for unknown angles or unknown side lengths. So the sine law is one of those options. So this is what you want to use if you are trying to find unknown sides or unknown angles in what we call an oblique triangle, which is a triangle that does not have a 90-degree angle. So for this triangle ABC, we've got the side lengths labeled as ABC as well, with the opposite side to the angle the opposite side and opposite angle, the letters match. So angles we label with uppercase letters and side lengths we label with lowercase letters. And side A would be opposite to angle A, side B is opposite to angle B, and side C is opposite to angle C. So if this is how our triangle is labeled, then there's two different ways that we could write out the sine law. One way is by saying that sine A over A is equal to sine B over B is equal to sine C over C. And you'll notice that here we have the angles are in the numerator. And so this option for sine law, or this version of sine law, is very helpful if we are trying to find an unknown angle, because it means that the unknown angle will already be in the numerator of our calculations. If we take the reciprocal of each of these ratios, we get A over sine A equals B over sine B equals C over sine C. And we notice here that the side lengths are in the numerator. So this version of sine law is going to be very helpful when we're solving for side lengths, because the side lengths, the unknown side length would already be in the numerator of our calculation. So this video is not going to go into the detail of how the sine law is derived. That can be a fairly lengthy proof for grade 10 students. If you're interested in that, however, either let me know, or there are some other resources that you can take a look at online. If we were teaching this lesson in a regular classroom setting, then we would probably be going through the proof of sine law and why this sine law works. For now, we're just going to use this relationship between the sides and angles in any triangle in order to solve for unknown sides or unknown angles. So here's our first question. It says determine E, so determine side length E. I know it's a side length because it's a lowercase letter. So determine side length E rounded to 1 decimal place. So the first thing we take a look at is we notice that this is not a right triangle. So neither of the two given angles are 90 degrees. And if we determined what that third angle is, it's also not a 90-degree angle. So we cannot use Pythagorean theorem or the primary trigonometric ratios to solve for unknown sides or unknown angles. So we attempt the sine law. Because I'm solving for an unknown side here, I'm going to use the sine law where the side lengths are in the numerator. So because this is triangle DEF, I'm going to set up the sine law so that I have the variables are matching the diagram that I have. So D over the matching angle is angle D. So D over sine D is equal to E over sine E is equal to F over sine F. Right? Now we only need two of these ratios in order to solve for an unknown. Okay? So here, I know that I want to solve for angle E. So I'm just going to put a question mark here because that's what I want to eventually solve for. Okay? Right now it's an unknown. Otherwise, I'm going to put a box around everything that I know from this diagram. So angle D, I know what the value of angle D is, so I can calculate sine of D. I know what side length D is. That's the one that's opposite to angle D, so I know this value. And I also am given angle E, so I know this value. I actually don't have any information about angle F or side F. So if I look at these two ratios here that are equal to each other, I have 3 of those pieces of information, and I'm missing the 4th one. The only one I'm missing is the one that I want to solve for. So I'm going to use the proportion d over sine d is equal to e over sine e. If we fill in all of our known values here, we'll be able to solve for side length e because that will be the only unknown remaining. Okay? So because I don't have any information for this third ratio, f over sine f, we aren't going to be using that in our calculation. We only need 2 of these ratios to be able to set up this calculation. Okay, so now we substitute in the values that we know. So side length d is the 10 centimeters. Angle d is 48 degrees. Side length e is our unknown, so we leave that as the variable e. And angle e is 36 degrees. Okay, so now we have an equation that we can solve for side length e. So in order to solve for e, I need to get rid of this sine 36. So we multiply this side by sine 36. And that means that we have to do the same calculation on the other side of the equation. So we also multiply this side by sine 36. So now I have that side e is equal to sine 36 multiplied by 10 divided by sine 48 degrees. So we want to type that calculation into our calculator all at once so that we don't have to round anything other than our final answer. And we get the answer E is about 7.9, and the units would be centimeters because one of our other side lengths was already given in centimeters. So we know that our answer would also be in centimeters. So side E is 7.9 centimeters long. Okay, our next question. Here we're going to solve for an unknown angle. So again, we quickly do a check to see if Pythagorean theorem or primary trig ratios would be applicable here, and neither one of them is applicable as this is not a right triangle. So we set up the sine law, and this time we're setting up the sine law for triangle x, y, z. So we're going to use x, y's, and z's when we write out what the sine law looks like. Because I'm solving for an unknown angle, I'm going to use the version of sine law that has the angles in the numerator. So sine x over x equals sine y over y equals sine z over z. And then we're going to go through, just like we did last time, and check off the information that we know and identify the information that we want to solve for. So here we want to solve for angle y. Okay. We are given information about the side that's opposite to angle y, so that's side length y. We know that one. We're also given angle z, so we know what sine z is, and the angle opposite, or the side length opposite that angle, which is side length z. So in this case, we don't have any information about x at all. So we are going to be using these 2 ratios in order to solve for our unknown. So here we would have 3 pieces of known information, and our 4th piece is the angle y that we will be able to solve for. So we're using the ratio sine y over y is equal to sine z over z. So we fill in our known information. Sine y, angle y is our unknown, so we leave that as the variable y, over side y is 35, equals sine z, angle z is 31 degrees, over side length z, which is 26. So here we want to get sine y by itself. So in order to do that, we need to get rid of the 35, and we do that by multiplying both sides of the equation by 35. So here the 35s divide out, and we're left with just sine y. So we have sine y equals sine of 31 degrees multiplied by 35, and all of that is divided by 26. And just like with our primary trigonometric ratios, anytime we need to solve for an angle, we need to take the inverse. So in this case, the sine inverse. So angle y is going to be equal to the sine inverse of everything that was on the right-hand side of this equation. So again, as much as possible, you want to try doing this entire calculation on your calculator in one shot so that you don't have to round numbers and then round again when you get to your final answer. Ideally, you want to just round your final answer and not round each of the steps. So if we do this calculation on our calculator, we should get that angle y is about 44 degrees. Now, in some cases, when you're applying the sine law, you may not necessarily have enough information right at the beginning of the problem in order to use sine law directly. You may need to, for example, use the idea of the angles in a triangle add up to 180 degrees. And so maybe you need to solve for an unknown angle first, and then you have enough information to use the sine law to solve for something else. Uh, or you may need to use the sine law to solve for another unknown side or angle, and then use the sine law a second time in order to solve for the unknown side or angle that you actually want as the answer to your question. So some questions may involve applying the sine law more than once to get your final answer, and some questions may involve using some other trigonometry or some other angle rules, and then using sine law before you get to your final answer.